Hello, dear Kia family members. First of all, on behalf of Kia management, I would like to thank you for your continued effort for the globalization of Kia Motors with quality after-sales activities. This videotape was produced for the purpose of service training on the Opirus. This videotape contains engine, automatic transaxle, chassis, and electrical. Let's start with the engine system applied in the Opirus. The Opirus adopts Sigma's 3.5-liter V6 DOHC engines, which are similar to the Sorento 3.5-liter gasoline engine. Now, let's take a look at the major characteristics of the Sigma 3.5 engine. The Sigma 3.5 V6 DOHC engine uses a Melco EMS system, which has been used in the Optima 2.4-liter and Sorento 3.5-liter engines. Let's review the major differences of the Sigma 3.5-liter from the one used in the Sorento. The Opirus has a front-engine, front-drive type installation. The electronic control variable intake system, EGR system, Smartra standalone type immobilizer, and the newly adopted electronic throttle system. Now, let's move on to the timing belt. The Opirus timing belt, one cogged tooth timing belt, drives 4 sprockets and the water pump, and is kept under proper tension by a hydraulic auto timing belt tensioner. When assembling an engine, be attentive to the following. Install the timing belt using the marks on the right or left side of the bank. Install camshafts not by the machining mark, but by the identification mark, and also the intake and exhaust sides of the cylinder heads. Now, let's review the major components. First of all, a 16-pin data link connector, RCT connector, passenger side junction box, antenna unit and BCM are installed in the passenger side compartment. Major items installed in the engine compartment are the ETS assembly, 20-pin data link connector, junction box, APS, ETS relay, ignition failure sensor, and map sensor. For communication with diagnostic tools, a 16-pin data link is mainly used, and an RCT connector is used for ECM ROM data changing and basic ignition timing checks. To check the basic timing ground, the RCT pin number 3 is normal if the timing is 5 degrees plus or minus 2 degrees before top dead center when checked using a timing light. Now, let us review the major inputs and outputs of the engine. As for the major inputs, there are the oxygen sensor, Hall type CKP and CMP sensor, MAF and IAT sensor, TPS, ECT, knock sensor, ignition failure sensor, MRS motor rotation sensor, and power steering switch, and the EGR valve, injector, PCSV, and VIS are the main outputs. The ignition failure sensor is used to supply power to the ignition coil and to detect mainly secondary misfiring. Synchronizing waveforms through the CKP and CMP are as follows. It cannot be started if either the CKP or CMP has a failure. Zirconia-type oxygen sensors are used for front and rear. Here are the basic engine RPM and ignition timing specifications under normal conditions. The overrun fuel cut limits engine RPM to 4,700 in P and N range to prevent engine overheating. Unlike the vacuum-type VIS adopted in the Sorento, the Opirus adopts a DC motor-type variable intake system. Major components are a DC motor to change the length of the intake runner and MRS1 and MRS2 of Hall-type motor position sensors to detect the shutter position. The VIS operates in the range from 4,000 to 4,500 RPM in 9 steps, and it opens fully above 4,500 RPM. When the DC motor and MRS fail, they cannot be replaced separately, only as an ICV, in-duct control valve assembly. Let's take a look at the electronic throttle system. The ETS is also referred to as the drive-by-wire system. Eliminates the mechanical element. Improves drivability through accuracy of air intake control. Satisfies the strict exhaust emission regulation. Eliminates additional components for subsystems such as cruise control, traction control, and idle speed control. And increases serviceability and system reliability. Let's take a look at the main components of the ETS, which are ECM, ETS unit, throttle motor, fail-safe motor, TPS, APS, and ETS relay. The APS has 2 potentiometers used as APS1 and APS2. APS1 is used as a subsignal to the ETS unit, and APS2 is the main signal to the ECM. APS has 8 terminals with an idle switch. Both APS1 and APS2 signals show the same data range from 0.45 volts at idle to 4.8 volts at wide open throttle. The idle switch output shows 0 voltage at idle and 5 volts off idle condition. The ECM is located at the center panel base, and its main functions are to calculate the target throttle opening, to generate the throttle motor activation signal to the ETS unit, to perform serial communication with the ETS unit, and to control the fail-safe function when the ETS system fails. The ETS unit is located below the passenger side dash panel. Its main function is to generate throttle motor activating current and feedback control of the target throttle opening. The main purpose of the TPS is to detect the throttle valve opening and feedback of the throttle motor position. A 2 potentiometer type sensor is used. TPS1 is the main sensor to the ETS unit, and TPS2 is a fail-safe sensor for the ECM. TPS1 ranges from 0.3 volts at idle to 4.7 volts at wide open. The TPS2 valve is opposite. It starts from 4.7 volts at idle and drops to 0.3 volts at wide open throttle. When the difference between the TPS1 and TPS2 valves exceeds 1 volt, the ETS switches to limp home function. A 3-wire brushless servo motor is used for throttle motor activation. There are 3 connections of W, U, and V with 4 phases. When U and W become low and V becomes high, the motor turns right 30 degrees. Each coil's resistance is 0.6 to 1.5 ohms. If maximum resistance variation between the three coils exceeds 0.5 ohms, proper ETS operation cannot be guaranteed. The limp home mode activates the fail-safe valve when ETS problems are detected, such as throttle motor open or short circuit, throttle motor stuck open, TPS and APS fault, ETS unit fault, ETS relay fault, and RPM drop by electrical load. For any of the conditions above, the engine RPM is set to 1,500 to 2,000. Initialization has to be done in the following cases to learn the exact throttle motor position. After production in the factory, throttle motor replacement, throttle body replacement, TPS replacement, and after repairing an ETS problem. The procedures for initialization are follows. First, erase the trouble codes from the ECM and ETS units. Second, turn the ignition key on, less than 1 second. Third, turn the ignition key off until the main relay turns off, usually about 10 seconds. Finally, turn the ignition key on for more than 1 second to hold the throttle motor position. We've learned the Opirus engine so far. Now, let's move on to the automatic transaxle. The Opirus adopts the same 5-speed automatic transaxle installed in the Carnival 3.5 liter. Noise, vibration, and harshness levels were greatly reduced. The F5A51 consists of 4 clutches, 3 brakes, and 2 one-way clutches. Compared to the 4-speed automatic transaxle used in the Optima, a direct clutch, a reduction brake, and a one-way clutch for the sub-shift section are added. Compared to the 5-speed automatic transaxle used in the existing Carnival 3.5 liter, 4th gear ratio has been changed. This is achieved by using different operating elements in 4th gear from that of the Opirus. In the current 5-speed transaxle, the reduction brake operates through in 3rd gear and is released in 4th gear. To reduce judder when shifting from 3rd to 4th gear, the reduction brake remains engaged through 4th gear and is released in 5th gear. As a result, 4th gear ratio is increased and direct clutch operates only in the 5th gear. This new shift design will be applied to all 5-speed HiVec automatic transaxles in the future. It will also be applied to current production of the Carnival 3.5 liter. Other components, such as hydraulic control and electronic control, are the same with those of the existing transmissions. For more information, refer to the HiVec training module from Kia Motors.